Hi, my name is Peter Pilgrim. I am the founder and organizer of the Java Web Users Group in the UK. On my trip to JAVAONE 2006 this year, I attended a few technical sessions and one caught the eye really magnificently. It was the technical session 1297, Filthy Witch Clients, Animated Effects in Swing Applications, and the speakers were Kenneth Russell, Romain Guy and Chet Haas. It was all about animation and what you can do with the Java Swing classes and what's going on in the Swing labs. I found it an outstanding example of what you can do with Swing. And Romain Guy demonstrated a mashup of Flickr, Google Maps, that he presented in the keynote on that morning of Tuesday, the 16th of May 2006. It's well worth a look, and it comes up first in this video. Enjoy this one, especially from me.
The development version of it, but we're going to promote it into the official reference implementation. Now, this library supplies a widget, a GLJ panel, which gives you the ability to do 100% correct swing and 3D integration. But unfortunately, the performance of this is not that great. The historical problem here is that if you want to get the best 3D performance out of the platform, you've had to go to a heavyweight component or an AERITH-based canvas subclass. And as we all know, there's the problem, the famous problem of mixing lightweights and heavyweights, where your swing components are going to be, occluded by the heavyweight components if you place them side by side. So, if you want to get 100% correct swing and 3D integration, this is what you have to do. First, you render to an off-screen key buffer, which is an OpenGL concept, and that path there is actually hardware accelerated, so that's fast. Then you have to copy the frame buffer back into the raster of a buffered image. That's not fast. And then you draw that buffered image using swing over the entire area of the component. And despite Swing and Java 2D's best efforts, that's also not fast. And the reason is that the contents, the entire contents of the buffered image, are changing every frame. So there's no opportunity for the Java 2D implementation to cache the bits in VRAM. So Chris Campbell from the Java 2D team and I have done some experimental work in the Mustang release. There's definitely some more work to be done in Dolphin Java SE7 to standardize these APIs, but here's what we've got so far. Third-party libraries have a little bit of a backdoor to interact with the Java 2D OpenGL pipeline. So this is not the default on any of the platforms, but it's available on Windows platforms, on X11 platforms like Solaris and Linux, and is forthcoming in Apple's Mustang implementation on OS X. And these sort of semi-hidden APIs allow access to the OpenGL draw with the context and the rendering thread. So we also built into the Joggle project a little bit of a bridge to this to these new APIs. So the Swing-compatible components in the Joggle library will now use this API to the Java 2D OpenGL pipeline when it's available. And this basically gives you the same speed as using heavyweight components, but also gives you 100% swing integration with no application changes. So can we switch to the demo machine, please, and let's show you what you get with this. Okay, so this is where we stood before the integration work. Okay, so what we have here is a swing compatible 3D component. The gradient in the background is being drawn with Java 2D. Okay, so the normal 2D APIs that everybody's familiar with. The components, the images in the lower left, the icons, and the text in the lower right, those are also being drawn with Java 2D. So those images are buffered images, and the text is just normal drawstring calls. Okay, and then sandwiched in between these these graphical elements, you have the 3D output. Okay, so this all looks pretty good, and you can get some, pretty nice visual effects. The problem occurs when we make the window bigger, and we can see that the frame rate slows down. Right? That's somewhat unfortunate. So this, ladies and gentlemen, is what you had before Mustang. this is what you get with Mustang.
Oh, yeah.
Any
All right.
questions?
Yeehaw!
Thank you. So, moving a car, crappy car, on a crappy track is nice. I had a lot of fun doing that kind of stuff, but in the end you have to write real applications. So, if you were at the keynote this morning, you've seen a demo, a swing demo that we did, and I'm going to use this demo to show you what you can do with animations in your applications that you're doing every day.
This is Romain Guy.
So first, let's talk again about what Chet said before. Life is restless. Everything is moving. Nothing is changing at once. Things are evolving, mutating. Well, you all know that. Things are moving. So we have to integrate that in our applications because most of the time the applications just change in a snap. And that looks bad, really bad. And sometimes it's even bad for the user because you are kind of lost. You don't know what happened on the screen. You just know that something happened. You don't know what. And also the thing is, all our applications are in 2D, and 2D is boring because life is in 3 dimensions, and sometimes it would be nice to have the 3rd dimension in the applications just to spice things a bit. So with that, let's go to the first kind of animation you can do in your applications. Those are the transitions. So the transitions must be used, and I say must be used, whenever you are changing a value in a component that remains on the screen. When you are changing the text of a label, the text of a text field, an image in an image container, whatever, apply a transition. So the transitions, there are various kinds of transitions, but some of them are really easy to implement, and they look really good. I'm talking about the fading and the fade out. So the fading can be done in 2 different ways. You can fade to and from a color. For instance, your image can disappear with a fade to the black color. Or you can do an opacity change, where the component just disappears and fade into whatever the background is. We also have a crossfade, and a crossfade is basically a fade out of the old value and a fade in of the new value. This is also really easy to do because once you know how to do the fade in and the fade out, you get the crossfade for free. And Strings makes that really easy to implement. So the example we have here is the tiny code that you can use to create a fade to black. So this is, you don't see the animation in the demo, but first I want to bore you to death with the code. We have a bunch of lines of code that you saw earlier, but the interesting part is first in green, where we create a property range. So we have a property called fade out, with a value that goes from 0 to 1. So basically, 0 means that there is no black color on the screen, and 1 means that everything is black. Then we just set up the object modifier to actually call this fade out property on the current object. So this can be a label, a custom component, whatever you want. We set up the timer, and a very important part in this example is to set an acceleration and a deceleration. I've seen many fade in and fade out, but they don't look good because they don't use nonlinear movement. For instance, on the web, fade-ins and fade-outs are starting to appear with all the Ajax bars, but very few of them use nonlinear movements. So since it's very easy to do with the timing framework, just go ahead, it's really nicer. So this is the actual painting code that the timing we just set up will call. So we set up our property with a simple setter according to Java spec. And the only trick here is to call repaint to update or refresh the component. We also, in this case, we override the paint component method to draw a black rectangle on top of the actual component so you can do your fade to black. So you're still drawing the component, but you just put on top of that black rectangle. And as you can see, we're using a new color object, and the last parameter is actually the opacity of the color. So we take a black color and we change its opacity from 0, that is totally transparent, to 1, totally opaque. And if you draw that on top of the existing component, you'll get your fade to black. So in just a few lines of code, you can already improve the appearance of your application. The next kind of effects that you can easily integrate into your UIs are the highlights. So you have to use the highlights whenever you want to attract the user's attention on a specific part of the UI. You must not abuse them. It's really easy to abuse them, and you end up with having sort of a clone application. Some of the most common effects include the brightness increase. So when you mouse over a picture, for instance, it gets the brightness just increase. You get the glow and the pulse, so you have sort of a blurred halo around the object that just appears, or with the pulse, it just appears and disappears, etc. Or the spring effect. This is what you get on the Mac OS X, for instance. When you double-click on an element to launch it, you just see the element grow and fade out. This is the spring effect. And usually all those highlights are triggered by user inputs, and most of the time this is a mouse over effect or a mouse exit effect. At the bottom you can see two examples of those highlights. So on the left we have the regular components. I'm not sure you can tell the difference in the back, but let's try. So for instance, the button on the left has a normal background, and the one on the right has a sort of white halo in the background. So when you move the mouse over the component, this halo will start to fade. The same goes for the label next to the button. We just increase the brightness of the text. So it's a little gray on the left and it's totally white on the right. So it can be very subtle, but the user will always notice that kind of effect, and it will make its life easier in many cases. So how we do that? Real easy to do. It looks really nice, and best of all, it looks complicated to do, so you can show your colleagues that you are really good at Java 2D. So in this case, we set the alpha composite for the glow. We draw the first image, that is the blurred version of the cup, with this new transparency. We restore the old composite, so we get back to full opacity. And we draw the actual Java cup without any opacity and without the blur. And it's all you have to do. Once again, real easy, so just do it. So we'll see a bunch of animations. We'll start with the fading. If the application starts. Here we go. So we have a fade-in for the logo of the animation. It was really simple to implement. We just had a fade to black. We just had a fade-in for the text field and the button. So we can tap login. Another fade-out. Here you can see the glow behind the Java cup. I hope you can see it sort of that. But you can tell that the circle is rotating. This is our indeterminate progress bar. And you can also mix the animation, so while we were fading out the screen, you could still see the animations going on. Then we have highlights. For instance, if I move my mouse over those labels and images, you can see the spring effect behind the icons. So this can be very subtle, but it looks really nice, and I'm sure your users will love it. We talked about crossfade. So here we have crossfade between the screens. Once again, it was quite easy to do. Actually, Chet wrote something for that. Will you realize it? Okay, he will realize it when it's fine. And this screen is very interesting also for the transitions, because when I will click on an item on the right, I will reuse the components on the left, and I will just change the value. I will just change the text of the labels on the left. And in order to do that, I used fade-ins and fade-outs to make the transition much smoother, and it's better to look at that rather than an ugly gray application that just swaps the values at once. We were talking also about 3D. It's about time we use the 3D in this UI. So once again, the crossfade. And this is OpenGL running in the Swing application and leveraging the work done by Ken. So you can't really see that, but the buttons at the bottom are actually JavaWUG, and they are positioned in the Swing container. The white rectangle is a Swing panel. And the pictures have a reflection, and the reflection shines through the panel. And we can only do that because there is this nice integration between Swing and OpenGL. We also have multi-step animation. For instance, if I zoom a picture and I go to the next picture, we want to zoom it out, go to the next picture, zoom in. So this is an example of what you can do with multiple step animations. We have other highlights when we move the mouse over the buttons here. And let me show you some of the full animations. Just for the network. So I was talking about the motion, especially with drag and drop. So for instance here, I can drag those pictures around, and when I miss my drop, they just go back. So you actually know that you did something wrong, and you see the item go back to its original location. The highlights can also affect other properties than just color or brightness. So for instance, if we want to show where the user can actually drop the item, we can just use a simple scale animation. You can see that this is a hotspot in the UI that you can actually interact with it. And finally, we have fades in and fades out everywhere. So it wraps up this section of the talk. Chet, you want to conclude?
Switch back to the slides now.
You can easily change the foreground and the background colors. You can change the location and the size for many simple animations that will really enhance your user interfaces. We also provide some advanced components, particularly in the Swing-Labs project. We have a super cool component called the JAX panel. It has a property called alpha, and it allows you to change the opacity of the component and of all the components that you put in this panel. So this is what I used throughout this demo for all the fades in and fade out. You just put everything in the JAX panel, you set the timing controller with the property range, and you're done. And last but not least, keep your animation short and simple, because we all know how boring an application can be if we just spend all our time watching those long animations that looks nice the first time, but they are really boring the second time. So it's your turn.
Thanks.
Nice segue.
So, by the way, I thought we should have an equation here.
My case Swiss, I dare not go onto the beach in case I get them so soiled up and dirty.
Right, I open a new tab, right? And I start, I go away, I'm starting to book a hotel, blah, 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 and it's not my hotel.
This is
Alright,
Gafter
now I'm
demonstrating the scene.
book a double T, I've got a confirm button. Alright, now let's say my AED strikes, and I'm like, yeah, let's stay at the Ritz. Alright, let's see. Now we're in the confirm by page for the Ritz-Carlton. And then I swap back, right? And I go to press confirm here. Now, on almost every web application I've ever used, if I press confirm now, I'd have booked myself into the Ritz-Carlton for like $450 a night or something. But here, no, it books me into the DoubleTree. Because the state was held in the conversation. The state of this booking was held in the conversation context. And that conversation was associated with that particular tab in that particular browser window. So this whole problem of a multi-window operation just falls out naturally. I mean, there's a whole bunch of other stuff I could show you. I could show you how I can back button freely here and go and it all works, and I confirm there and that all works. And then what happens if I back button again and press confirm? Normally I'd most web applications I'd make 2 bookings, right? But if I do this here, actually it says no conversation. Just to test that. And so you're writing Java code to do this stuff. It's just natural when you have a conversational model. A whole bunch of problems I don't have time to talk about with respect to refresh buttons, back buttons, multi-window operations, big all kind of bugs that are just endemic in the web just fall out when you use conversations. Can we go back to the slide, please? It's something where when I'm browsing around here, this needs to be a stateless thing, right? So when I'm browsing around, viewing my search pages. Hey. Thank you very much. Appreciate it. I can add these things to my shopping cart, and this is a purely stateless thing. I can navigate completely ad hoc, right? When I go to check out, then I begin a wizard, right? So I can go here and once I went here, I began a page flow. The page flow looks like this, right? And so click purchase, click confirm. Right, I was executing the page flow, right? And now I've got an order, right? And what actually happened when I created that order was I began a business process. Right, so I was executing a page flow, that was a conversation, page flow was a script for a conversation. At the end of that conversation, I began a business process. Let's talk about business process and then let's see that, which actually makes for a bit more interesting demo. Let's go back to the slide, please.
Yes. You can use Sync just in Tomcat, right? You can actually like our embeddable EJB3 container and stuff deploys on Tomcat or else.
But the best way to go is just to take the
best way is you need Java SE5. The best way is a full Java EE5 environment.
Okay.
Then you get.
For the JVPM, do you need a database?
Do you need a database? Yes. Not for the page flow, but for business process flow. Yes.
Yeah.
The JVPM stores its state in the database. Absolutely. By the way, guys, I'll probably have to get out. If anybody has any questions, please come to the JBoss booth, and I'll be there today and tomorrow and stuff.
Thank you, Gavin. That was a great presentation.
Thank you.
Cheers.
The next one will. This one's going only to Chinatown. Chinatown only. Chinatown only. Y'all going to the long day.
Long day, you want to start walking with skills phone.
Oh, that's I'll trade. Come back tomorrow. You drive, I walk. Show up. You drive, I get paid, and I'll walk with her.
That's how they turn the tram around. I think this one is going to Chinatown. So I'm going to get the next one. Get them to the other side. To the wall.
That 5 years ago, we were at Oracle Open World, and that's where we did the first puzzles presentation ever. So it's great to be back. Neil, why don't you give them the first puzzle, all right? So this one's called Odd Behavior. It's a program that starts with a list of numbers and prints out whether or not it finds an odd number in the list. And my question for you and for our audience is, what does this program do? Well, of course it's got to find an odd number, right? I see like a 1 and a -1, but let's take a look at it. So all it's got is this main method and this isOdd thing. Let me look at isOdd first, just to make sure it works, because I know that these methods don't always work. Let's see, isOdd takes an integer and it returns I and 1. That's the bitwise AND operation, so it's just looking at the right-hand bit. And it returns true if the right-hand bit, the least significant bit, is 1. Otherwise, it returns false. So this correctly determines whether its integer argument is odd. I like that method. Okay, let's look at the main method. We have a list of integers. We initialize it to contain -2, -1, 0, 1, 2. These are consecutive integers from -2 to +2. Now we keep track of whether we have found an odd number in this found_odd boolean. We iterate over the list. This is the standard idiom for iterator of integer it equals list.iterator or it.has next. And we accumulate into found_odd. So we set found_odd to found_odd, or if the next number is odd. So basically, we just iterate over the entire list, and if we ever get an odd number, found_odd becomes true, and it stays true. Okay? And yeah, the second number in the list is odd, so I would say that when we run the when we run this, found_odd will be set to true, and it will print true. It's got to be true. All right, that's plausible. Let's see what our choices are. Your choices are true, false, throws an exception, or none of the above. So we'll give the audience a minute to think about this.
We'll give the audience 10 seconds.
Okay.
This is an easy problem.
All right.
Your time is up.
So all of those who agree with Josh that this program will print true, raise your hand. All right. A few of you.
A smattering.
How about false? How many of you believe this program will print false? Almost no one. 5 or 6 people. How about throws an exception? A fair number of you, I'd say maybe 15%. How about none of the above? Most of you.
Now, this is a problem. I'm sorry. This is not a primary election. You've got to vote. Most of you weren't voting, so that would be the winning answer, not voting. I want you to run the election again.
All right.
Everybody.
And we're going to keep
cannot
doing
win
this.
if you do not play.
We're going to keep doing this until you all vote.
Okay. How many people say true? Raise your hand up high.
Okay. All right. That's maybe 30. I'd say maybe 5 to 10%. How about false? How many of you think this program will print false? Again, only a few. How about throws an exception? Wow. Okay, that's more like 30% maybe. How about none of the above? I'd say maybe half of you.
Well, let's see what it does.
The correct answer is this program does not do anything because this program contains an infinite loop. And the intuition is the conditional OR operator is a short circuit operator. So let's look at the program again and see how that works out. You see, when we're doing the accumulating the value into found odd, once we found an odd number, found odd is already true. And the short circuit operator does not bother to evaluate its right-hand operand when the left-hand operator is true. So here, we don't bother to do it.next. So the loop test, it.hasNext, remains true because we never advance it once we found an odd number. And since we find an odd number here in the list, we never advance it past the point of the 0. So that's why this program is an infinite loop.
Well, that's awful. How do we fix it?
Well, and to also answer the question, what does this have to do with Tiger? Here we have this nice new looping construct in Tiger. It's intended to help solve exactly this sort of problem. If you use the new for each loop, then the language construct ensures that it iterates to every value of the list on the right-hand side, even if the short circuit operator short circuits the evaluation of is odd, because it's the loop construct itself that does the advancement from element to element through the list.
Well, that's okay, but how else can we fix it?
Well, you could also write a contains odd method that really short-circuits the entire rest of the loop by returning true as soon as it finds an odd value. Because after all, once you found an odd value, there's no point in running through the rest of the loop.
So you're saying if the loop has 1,000,000 elements, and the first element is odd, why bother running through the last 999,999 elements?
Yep. Good. This version of the loop is short circuits, right? We have contains odd method. As soon as we find an odd value, we return true.
Yeah, that one's clearer and easier to read. So what can we learn from this one?
Well, the new for each loop is there for a reason, for a lot of reasons actually. Besides being prettier to read and nicer to write, it really does help you avoid this kind of bug in your programs. So you should use for each whenever it's applicable in your code. If you must use an iterator, there are a few reasons you might have to use an iterator. Make sure you call the next method on the iterator exactly once each time through the loop. And also, of course, the conditional operator only evaluates its right-hand operand if the value is not determined by the left-hand operand. So for the conditional OR operand, if the left-hand operand is true, then it doesn't evaluate the right. And the conditional AND operator only evaluates the right-hand side if the left-hand side is true. Usually that's what you want, but sometimes you actually want both sides evaluated
even though one side determines the result. And there are these Boolean logical operators, the single ampersand and the single vertical bar, that you can use to cause both operands to be evaluated. Although that's not the best way of fixing this particular problem.
Well, I'll be sure not to make that mistake again. Now, I have one for you.
All right.
We call this one set list, and we call it set list because we feel like rock and roll stars up on this stage, you see. So what this program does is it has one set and one list, and it does the same things to the set and the list, and then it prints out the set and the list. And what I want to know from you, Neil, is what does the program print?
All right, well, let's see. So it just, this class is really composed of just the main method. And it starts out with a set of integers, which is a linked hash set, which, if I recall, keeps its elements in order, right?
It does, yes.
And then we have a list, which is an array list, which also keeps its elements in insertion order.
Of course.
So for every int value from -3 up through, well, let's say less than 3, so it would be -3 up through 2, we put that value into the set. And I see here we're using auto boxing to turn the int value into an integer.
Indeed we are. This is Tiger.
So we add it to the set and we add it to the list. Now since both of those keep their elements in insertion order, we should have the same collection of values in each of those two collections. Then we go through the values from 0 to 3 and remove those. So those are all of the non-negative elements that are in the sets. And we remove that element from the set, and we remove that element from the list. So it looks like we're going to be leaving only the negative values in both the set and the list. And finally, we print the set and we print the list, both of which at this point should contain -3, -2, -1.
Okay? So you think it prints set
-3, -2, -1, space, and then -3, -2, -1 with great square brackets.
Well, let's see what the audience thinks. How many people agree with my brother that this program ought to print -3, -2, -1, followed by -3, -2, -1? Oh, we got a few smattering. Raise them high so I can get a good count. I'm going to say 5%. 5% of you think my brother got this one right. How many people think it should print -3, -2, -1 for the set, followed by -2, 0, and 2 for the list? Another 5% of you. How many people think it throws an exception?
Like what, class cast exception or something?
10% of you, anyway. And how many people think none of the above? 80% of you. Everyone's voting. That's great. Okay, let's find out what it does, shall we?
Yes,
I
please.
think it does.
It turns out that those of you who chose
B.
-3, -2, -1,
Oh,
-2, 0, 2.
Well, that's really weird.
You're correct. And the
Yes,
intuition behind this one is that when you mix auto boxing and overloading, you get nothing but confusion. Let's take a look at the program again. You see, the problem here is that we're iterating from -0 to 3 on an int value. When we call set remove of I, we're removing the value that is equal to the auto-boxed version of I. But when we call list remove of an int, well, heck, this is a method that's been around for a long time. It removes the ith value from the int. So instead of removing the values 0, 1, and 2, we remove the 0th value, the first value, and the second value. And if you think about it for a moment, you'll see that what you do is you remove all of the odd values. First you remove -3, then you remove -1, and finally you remove +1, leaving only the even values, -2, 0, and 2. So that is what the program prints, and it's a shame.
It is a shame.
So how do we fix it?
Don't use a list anymore, perhaps.
No. The way you fix it, list is good. And I'm sorry, it got hurt a little. You know, sometimes when you make an omelet, a few eggs get broken. So the way to fix it is actually fairly simple. If you want to remove the element whose value is I, cast that int I to an integer, forcing you to invoke the method that removes a t rather than the method that removes an int.
So why does one of the method calls work one way and the other one work the other way?
Well, because one is a set and the other is a list. Sets are not generally ordered, so set doesn't have the remove of int method, whereas list does.
I see. Okay. And for a list, the int method is an exact match for the one that removes the element at position. And
Yes, it is. And that's the way the overload resolution works. If there's an exact match, if there's something that works without using one of the new language facilities like autoboxing, then you end up with that overloading. And that unfortunately is what's happened here.
I see.
So what can we learn from this one? Well, the moral is simple. And it's a moral that's an effective job. Avoid ambiguous overloadings. Whenever you have multiple methods that could conceivably get called on the same set of arguments, that is a bad thing. It turns out that it's much harder to avoid such overloadings in Flickr than it was before. And the reason is because autoboxing, var-args, and generics all increase the sort of applicability of methods. So you often end up with many more methods that could conceivably be applied to a given set of arguments. And you have to design new APIs with this in mind. It used to be sufficient merely to either give all of your methods a different number of arguments, or if you had to give them the same number of arguments to make sure that matching arguments were, primitive types in one method and reference types in the other. But that doesn't work anymore. You have var-args, so you can end up with things that have different numbers of arguments still matching the same arguments. And because of autoboxing, you can end up with an int argument matching an integer parameter, as we saw in that example. Luckily, very few existing APIs were compromised. The only one that I know of is list.
All right. So I have a problem for you.
Here we go now. This is Struts Tie. What's new in Struts Tie? I'm walking straight up to the podium now. To the right of me is Don Brown. In front of me is getting hooked up now is Jason Careirra. And that is Patrick Lightbody who did the presentation.
This is how big
So these guys are just clearing up, the Webflow guys.
Oh yeah, that's true.
And we're in a big room, E305, 3707. And I'm all the way down at the back, plugged in with my laptop.
Francisco, where we are right now, a maximum price. I don't want to pay more than $25. Let's see what low fares are available to other cities, and I want to leave 7/1/2006, and I press enter, finding cheap fares. All right. Well, I found out that this particular program doesn't allow for prices below $50 because that's crazy. No one flies below $50, especially with gas prices these days. So that's nice. It told me that. And if we were to look at the form, you guys saw it a moment ago, that's all it is. It's just like what Jason showed you. There's no HTML. All the structure of the form is built up for you. And that's why the validation error was able to just get shown automatically for you, because we've set up validation rules on, for example, the maximum price. Well, the only problem is if we look at this URL again, we start from the beginning, and you kind of already saw a preview of it. This form doesn't tell you that the maximum price has to be $50 or more, for example. So we might want to change that form to make it look like that. And that's an example of where you get into flexibility of the UI tags while still gaining the structure they provide and the additional features that come around with them, like validation, but you also want the flexibility to edit them and refine them. So the requirement now is let's add a hint functionality. A little bit of text that goes below the form element that might describe what is expected in there. The way you do that, in the way one might do this, there's lots of options. The way one might do it is to actually just pass in a parameter called hint into this tag. And let's zoom in a little bit more so everyone can see this particular tag. You can see it there in the back? Yeah, I'll take that as a yes. So what we're seeing here is I'm adding a nested tag in the text field for the max price field on our action. The parameter is going to be called hint. And we'll just put some text that says fares less than $50 don't exist or something like that, right? We're just trying to tell the user that there's some constraints on the data that they're trying to enter beyond the obvious ones, like you should enter some values. All right, well that's the first step. We're able to now pass some values back into the form element, but we need to actually display it because that hint functionality is something unique to our application that we just built. So Struts allows you to override the elements of those templates, those UI tags that Jason was talking about. So the normal element, what it looks like is this. It's basically the closing. This is just the final part. They're broken up into pieces, and this is called control footer. And it's basically a closing table cell and a closing table row, which would be expected considering the output that came from those form tags. What we want to do is add some hint functionality. So let's copy this, and I apologize, I'm not jumping through all the directories. I've got some favorites here, but this lets us speed through it. So let's add a new file called controlfooter.ftl. This is in our WebEnv classes. It gets picked up from the class loader. And what we're basically doing is we're overriding the one that's bundled in the jar. So I can paste in here, and at this point, this file is now being read instead of the one we just saw. And if I wanted to add that hint functionality, I can just add a little break, a line break, put some italics, and the syntax you're seeing here is actually Freemarker syntax. The reason we use that to render all these UI tags is it's something that's available in various contexts. A JSP tag can still use Freemarker templates to render the HTML, but Freemarker can and Velocity even can. So it's something that is available to any of the users of Struts. So we say parameters hint, if it exists. If it doesn't, we'll print out nothing. And close our italics tag. So let's come back over here. We'll reload this page. And there it is. We can see it was that easy to continue to use the structure provided by the UI tags, but add features that are unique to your needs and our needs in our application. This comes up all the time. I don't expect that those basic UI tags provided are good enough for you. Every project I've ever done, and every project I'm doing right now, I have overridden at least one part of the templates, and if not all of them in some manner or another, because every application is unique. Well, this is an example of how to do it. So instead of throwing them away because they don't offer the flexibility you want, I really encourage you to do what I just did, which is extend them and change them a little bit. And there's reasons for that. It gives you a predictable DOM structure. And
there you go. How did you pass go?
It's fine, I just sat there.
All right, okay. We have audio. Woo! We don't have a speaker, but we have audio, so good enough. So,
can you guys hear us in the back?
Yeah.
What?
Yeah. Okay. What kind of shout?
This thing and pass the time. Do you have that one?
If you do that, it's going to be way too loud.
Yeah, man.
How about we put it over here so that we can all stand out here and then?
This is the world famous Java posse. And I've got 28 minutes of battery life.
Okay. Anybody who asks a question, you ask it loud.
Where's the beer?
Yeah, except that one. All right. So,
what was the reason?
We'll explain that.
Serve it to me on time. Yeah, my breakfast and my supper. Serve it to me on time. What I like about the woman, Lord, that girl, she's mine. I had to low down dirty, y'all. Low down dirty shame. Yeah, low down dirty shame. You know I love my baby, she wanna love some other man. Yeah, my girl. Oh, she's a country girl. Oh, my girl. Yeah, she's a country girl. I love that woman more than anything in the world. Oliver, help me out, son. Talk to me here, huh? All right. Bring it on. Come on.
And it gets better. These two go to blues.